What if everything you've been told about high blood pressure is missing the real culprit, and it's hiding in your body, not your salt shaker? Every time someone is told they have high blood pressure, the conversation almost always begins the same way. Cut back on the salt. For years, I accepted that advice without giving it a second thought. It sounded clean, logical, almost too obvious to question. Salt raises blood pressure. Eat less salt. Problem solved. But then I stumbled onto a question that refused to leave my mind. If salt is really the villain we've all been warned about, why do I know people who seem to sprinkle it on everything and still have perfectly normal blood pressure? And why do so many others carefully avoid salty foods, read every nutrition label, follow every recommendation, and still watch the numbers on the monitor refuse to come down? The more I explored human biology, the more uncomfortable that contradiction became. It felt like reading the first chapter of a mystery novel where everyone points to the same suspect, yet none of the evidence fully fits the crime. That's when I realized something that completely changed the way I think about hypertension. Maybe we've been looking at the final symptom instead of the hidden chain of events that created it. The human body is astonishingly intelligent. It doesn't simply allow blood pressure to rise without a response. Every second, the kidneys, blood vessels, hormones, minerals, and nervous system are communicating, adjusting, correcting, trying to keep everything in balance. If that system is designed so elegantly, why would one ingredient in a salt shaker suddenly overpower all of it? That question pulled me deeper than I expected. What I found wasn't a single missing piece, but an entire network of invisible connections involving magnesium, insulin, potassium, uric acid, and the processed foods that quietly became part of everyday life. Suddenly, high blood pressure stopped looking like a simple dietary mistake and started looking like a biological puzzle with layers most of us never hear about. I'm not inviting you to abandon conventional advice or chase miracle cures. I'm inviting you to do something I find far more interesting. Let's follow the biology wherever it leads and see whether the story we've been told about high blood pressure is only the beginning of a much bigger and much more fascinating conversation. And once I stopped asking what salt does to the body, I found myself asking a much more interesting question. What does a healthy body do with salt? That single question completely shifted the way I looked at blood pressure. I had always imagined sodium as something that simply enters the body and pushes blood pressure higher, almost like flipping a switch. But biology rarely works in straight lines. It's a constant conversation between organs, hormones, and tiny chemical signals that most of us never think about. When sodium enters the bloodstream, it naturally attracts water, increasing blood volume for a period of time. On paper, that sounds like the perfect recipe for higher blood pressure, but our bodies evolved with a remarkable safety system. Healthy kidneys are constantly monitoring pressure inside the circulation, and when they detect excess volume, they begin removing extra sodium and water through urine. It's a quiet correction happening behind the scenes, restoring balance without us ever noticing. That realization made me wonder why the same meal could produce completely different outcomes in different people. If the system is designed to regulate itself so effectively, perhaps the problem isn't always the sodium itself, but the body's ability to respond. The deeper I explored, the more one nutrient kept appearing in study after study: magnesium. I used to think of magnesium as just another mineral listed on the side of a supplement bottle. Instead, I discovered that it participates in hundreds of biochemical reactions, including the production of nitric oxide, a molecule that tells blood vessels to relax instead of remaining tightly constricted. Without enough magnesium, those vessels can become less flexible, forcing blood to move through a narrower path and increasing the pressure against artery walls. What surprised me even more was how modern life quietly works against us. Processed foods replace mineral-rich whole foods. High sugar intake may increase magnesium loss through urine, and even the soil that grows our vegetables often contains fewer minerals than it once did. Suddenly, magnesium deficiency no longer felt like an obscure nutritional topic. It felt like one small, but meaningful piece of a much larger biological story that many of us have been living without ever realizing it. But the more those connections started making sense, the more I realized there was another invisible force shaping the entire picture, one that most people associate with blood sugar, not blood pressure. I used to think insulin had a single job, helping move glucose from the bloodstream into cells. It seemed like a straightforward hormone with a straightforward purpose. Then I began reading about how deeply intertwined metabolism is with every major system in the body, and suddenly hypertension looked very different. What fascinated me wasn't that insulin exists, but what happens when it stays elevated day after day. The kidneys don't simply filter blood like passive machines. They're constantly responding to hormonal signals, and insulin is one of them. Higher insulin levels encourage the kidneys to hold onto sodium and, with it, water. The result is subtle at first, a little more fluid, a little more pressure, but over months and years, those small adjustments can become a chronic state rather than a temporary response. That idea changed the way I looked at modern diets. Maybe the conversation isn't only about how much salt we're eating, but also about whether our metabolism is constantly being told to keep it. Then another piece quietly slid into place. Fructose. Not the occasional piece of fruit, but the concentrated fructose hidden in countless processed foods and sweetened drinks that have become ordinary parts of everyday life. As the body processes large amounts of fructose, it produces more uric acid, and that's where the biology becomes even more intriguing. Elevated uric acid may interfere with nitric oxide, making it harder for blood vessels to relax, while also making it more difficult for the kidneys to eliminate sodium efficiently. Looking at these pathways together, I stopped seeing hypertension as the consequence of one bad habit. Instead, I saw a chain reaction. Processed foods may contribute to higher insulin. Higher insulin encourages sodium retention. Excess fructose can raise uric acid. Higher uric acid may reduce vascular flexibility and impair sodium handling. None of these processes happen in isolation, and that's what makes the human body so humbling. Sometimes the diagnosis we see is simply the final chapter of a story that metabolism has been writing for years. And just when I thought I had uncovered the missing link, biology introduced another character that seemed to quietly balance everything else: potassium. What I love most about studying the human body is that it almost never relies on extremes. Instead, it operates through relationships. Every signal is answered by another signal. Every force is balanced by another force. And health often depends less on eliminating one thing than on restoring harmony between many. That's exactly how I began thinking about potassium. Most of us recognize the word because it's printed on nutrition labels or mentioned alongside bananas, but its role reaches far beyond that simple association. Potassium helps blood vessels relax, creating conditions that allow blood to move more freely instead of pushing against narrowed arterial walls. At the same time, it supports the kidneys in eliminating excess sodium, acting almost like a natural counterweight within the body's own regulatory system. What fascinated me even more was discovering that potassium doesn't stop there. It also appears to influence the nervous system, particularly the sympathetic response that prepares us for danger. In short bursts, that fight-or-flight system is essential for survival, but when it remains overactive for long periods, it can contribute to tighter blood vessels and higher blood pressure. Adequate potassium intake is associated with helping maintain the balance of this system, reminding me once again that blood pressure is about far more than simple fluid dynamics. Then I started looking at the typical modern plate. Processed foods are often packed with sodium, while offering very little potassium. Meanwhile, many foods naturally rich in potassium, potatoes, sweet potatoes, tomatoes, cucumbers, eggplants, spinach, beans, chickpeas, and other legumes, are pushed aside by convenience foods that require almost no preparation. The pattern suddenly became impossible for me to ignore. Low magnesium, limited potassium, highly processed carbohydrates, elevated insulin, and increased uric acid don't exist as isolated events. They interact like instruments in the same orchestra, each influencing the next until the body gradually loses the balance it works so hard to maintain. And perhaps that's the most remarkable lesson I've taken from this journey. Sometimes restoring health isn't about finding a single enemy to eliminate, but about helping an incredibly complex biological system remember how to do what it was designed to do all along. And the more those pieces came together, the harder it became for me to believe that something as complex as blood pressure could ever be explained by a single rule or a single nutrient. One of the most humbling things about exploring biology is realizing how often the body whispers long before it ever screams. Small shifts happen quietly. A little less movement, a little more processed food, a little less sleep, a gradual decline in mineral intake. Hormones adjusting, blood vessels adapting, kidneys compensating day after day without asking for attention. Then one morning, a blood pressure cuff displays a number that suddenly makes everything feel urgent. What fascinates me is that hypertension may not always be the beginning of the story. In many cases, it can be the visible result of years of invisible changes taking place beneath the surface. And even after looking at sodium, magnesium, insulin, fructose, uric acid, and potassium, it feels like we've only explored part of the landscape. Researchers continue to investigate how vitamin D status, vitamin B12, homocysteine, chronic stress, sleep quality, and endocrine conditions such as primary aldosteronism may also influence blood pressure regulation. The deeper I read, the more interconnected everything appears. That's why I no longer think about health as a battle against one bad ingredient or one isolated number on a lab report. I think about resilience. I think about giving the body the resources it needs to perform the extraordinary balancing act it has been carrying out every second since the day we were born. None of this means ignoring established medical care or assuming every case has the same cause. High blood pressure is a serious condition that deserves proper evaluation and individualized guidance from healthcare professionals. But I do think there's value in asking better questions and becoming curious about the biology behind the diagnosis. For me, that's the most meaningful takeaway from this journey. The human body isn't a collection of disconnected parts. It's a living network where minerals, hormones, metabolism, kidneys, blood vessels, and even everyday food choices continuously influence one another. And perhaps understanding those hidden connections doesn't just change the way we think about high blood pressure, it changes the way we think about health itself, replacing simple answers with a deeper appreciation for the remarkable intelligence of the body we live in every day. If there's one lesson I've taken from this journey, it's that lasting health is rarely built on one rule, one food, or one quick fix. The human body thrives on balance, and even small daily choices can gradually shape the way it functions over time. Choosing more whole foods, getting enough sleep, staying active, managing stress, and staying curious about how your body works may seem like simple habits, but together they can support a healthier future. I'm curious to hear your thoughts. What's one small change you're willing to make for your health today? Please share it in the comments so we can all learn from each other. And if you enjoyed exploring the science with me, don't forget to subscribe and support the channel so we can keep discovering more fascinating health topics together.